As an Azure administrator, you must be prepared for planned and unplanned failures. There are three scenarios that can lead your virtual machine in Azure being impacted. Number one is unplanned hardware maintenance. Second would then be unexpected downtime. The third one is planned maintenance. Let's talk about each one of them one by one. An unplanned hardware maintenance event occurs when an Azure platform predicts that the hardware or any platform component associated to a physical machine is about to fail. When the platform predicts a failure, it will issue an unplanned hardware maintenance event. Azure uses live migration technology to migrate the virtual machines from the failing hardware to a healthy physical machine. Live migration is a virtual machine preserving operation that only pauses the virtual machine for a short time. But you will notice certain performance issues after or before the event. Unexpected downtime. Unexpected downtime is when the hardware or the physical infrastructure for the virtual machine fails unexpectedly. This can include local network failures, local disk failures, or other rack level failures. When this is detected, the Azure platform automatically migrates your virtual machine to a healthy physical machine in the same data center. And this is also called as auto healing. During the healing procedure, virtual machines experience downtime and in some cases also lose a temporary drive. What is a planned maintenance? Planned maintenance events are periodic updates made by Microsoft to the underlying Azure platform, and this is done to improve overall reliability, performance, and security of the platform infrastructure that your virtual machines run on. Most of these updates are performed without any impact to your virtual machines or other cloud services. Microsoft does not automatically update your virtual machine's operating system or software. You have complete control and responsibility for that. But the underlying software, the host, and the hardware are periodically patched to ensure reliability and high performance at all times. For redundancy purposes, we usually keep two or more systems in the design. This makes sure that even if one server goes down, there is another one handling business requests. We as admins also need to make sure that the hardware maintenance or patching of these machines do not happen at the same time. Microsoft Azure Availability Set is just that. It means that virtual machines that are kept in the same availability set will not be subject to a single point of failure, and not all of them will be upgraded at the same time. Virtual machines placed in an availability set should perform an identical set of functionalities and have the same software installed. Azure ensures that the virtual machine you place within an availability set will run across multiple physical servers, compute racks, storage units, and network switches. If a hardware or Azure software fails, then only a subset of your virtual machines are impacted, and your overall application stays up and continues to be available to your customers. When you want to build reliable cloud solutions, availability sets is an essential capability. There are a few things that you need to note when you're creating an availability set. For redundancy, configure multiple virtual machines in an availability set. Configure each application tier into separate availability sets. Combine a load balancer with availability sets. And always use managed disks with virtual machines. Another important concept of availability set is fault domain and update domain. When you put your virtual machines into an availability set, Azure guarantees to spread them across fault domains and update domains. A fault domain is essentially a rack of servers. It consumes subsystems like network, power, cooling, etc. So two virtual machines in the same availability set means Azure will provision them in two different racks so that, let's say, if the network or power failed, only one rack would be affected. So a fault domain defines a group of virtual machines that will share a common set of hardware switches that share a single point of failure. For example, that will be a server rack serviced by a set of power or networking switches. Virtual machines in an availability set are placed in at least two fault domains. But this mitigates against the effects of hardware failures, network outages, power interruptions, or software updates. Let's talk about update domain. Sometimes you need to update your application, or Microsoft needs to update the host on which your virtual machine is running. Now, with IaaS virtual machines, Microsoft does not update your virtual machines. You have complete control and responsibility over that. But let's say if a serious security vulnerability is identified and a patch is created, it is in Microsoft's interest to get that applied to the host underneath your VM as soon as possible. So, how is that done without taking your service offline? Update domain is the answer. It is similar to fault domain methods, only this time, instead of accidental failure, this is a purposeful move. This is a purposeful move to take down one of your servers. So to make sure your service does not go offline because of an update, it will walk through your update domains one after another. So what is an update domain? An update domain allows Azure to perform incremental updates across your deployments. Each update domain contains a set of virtual machines and they are associated physical hardware which can be updated and rebooted at the same time. During a planned maintenance, only one update domain is rebooted at a time, but by default, there are 5 update domains. But you can configure up to 20 update domains if you like.
Creating and maintaining virtual machines can be a lot of work, and most of it is repetitive. And this requires same steps each time. After provisioning the virtual machine, sometimes you have to install other components like monitoring agents, configuration management agents, backup applications, antiviruses, etc. Installing and configuring these little applications can take time as well. VM extensions is a method to inject these applications during the VM provisioning so that you do not have to configure them repeatedly in every virtual machine in your infrastructure manually. Azure has lots of virtual machine extensions in its library. However, if you would like to customize installation of your app, then you can write your own script and upload it from custom script extensions. Your script can include PowerShell commands that you want to execute on the virtual machine. Once the file is uploaded, it will execute immediately. There are certain things to consider. When you're writing the script, make sure that you consider these points before you deploy it using custom script extension. Timeout. Custom script extensions have 90 minutes to run. If your deployment exceeds this time, it is marked as timed out. So keep this in mind when designing your script. And of course, your virtual machine must be running to perform these tasks. They cannot be in shutdown mode. Always consider dependencies. So if your extension requires networking or storage access, make sure that the content is available. Be sure to account for any errors that might occur when the script is running. For example, running out of disk space or security and access restrictions. What will the script do if there is an error like that? Consider handling sensitive data. Your custom script extension may need sensitive information such as credentials, storage account names, and storage account access keys. How will you protect and encrypt this information? Let's go ahead and look at the extensions feature in the Azure portal. I've created the virtual machine right here and its name is new VM. The extension option is available under settings. So if you click on settings, you will then see the add button. we can then click on this add button to see all the extensions that Azure has as on today. So if you are using Acronis Backup to back up your infrastructure in Azure, you can just click on it and then install. Microsoft Anti-Malware can be installed, Chef extensions, and there are a lot of these extensions that are pre-built for us, so we do not have to write a script to install these agents. But let's say the application that you want to install is not available in this list. Then you might want to go for a custom script extension. So if you would like to go for, let's say, Microsoft Anti-Malware, you can just click on it and then create and then specify the parameters of the antivirus. You can of course modify this later, but I'll click on OK. So what this means is that the virtual machine will now have this Microsoft Anti-Malware installed in some time. I can add multiple extensions at the same time. Let's add a custom script extension. Now, for me to add a custom script extension, I should have created a PowerShell script beforehand. Then I click on the Browse button and then browse to that PS1 file. Additionally, you can pass arguments or syntaxes to that PowerShell file. Now, while my Microsoft Anti-Malware is getting installed on the virtual machine, I would like to go ahead and create a script so that I can then pass it as an extension to this virtual machine. I'll click on Add and then click on Custom Script Extension, Create, to add a PowerShell. Now, let's go ahead and write a small PowerShell script. I will launch PowerShell ISC here and then write a small script called install-windows feature name, and I want to install a component called web server on that Windows machine. Let's start something small. So let's just start by installing this Windows component called web server. So this should go ahead and install IIS on my Windows based machine. I'll save it as a PS1 on my computer. So I'm saving it as install web service.ps1 inside the script extensions folder. Now it is saved. Now you can go back to the custom script extension and then click on this browse button to browse to my file. So I'm here in the script extensions pointing it to install web service.ps1. Upload is complete and then I just click on OK. I'll wait for the deployment to complete. Parallelly, I can just go ahead and click on Overview and connect to this virtual machine quickly so we can then log in and check if the installation has happened. Okay, so it looks like my virtual machine is ready. I will connect to the PowerShell here and see if I have, I'll just type get-windows feature to see the IIS component if it is installed on this machine or not. So it looks like there is a lot of data that popped up. So I will just say get-windows feature, narrowing down to web server. Okay, so it looks like it is installed. At this point, we just noticed that the IIS is installed on the machine, and this was installed through custom script extensions. Let's also go to the add remove programs to see if the antivirus is installed, which is Microsoft Anti-Malware should be installed through. Yeah, so this is System Center Endpoint Protection, which is nothing but Microsoft way of representing its own antivirus. So System Center Endpoint Protection, Anti-Malware is installed on the machine. Now, if you go back to the Azure interface under extensions, we'll see that IaaS anti-malware provisioning is succeeded, and also custom script extension is right there, but the status is unavailable. So we should just wait for some time and then we'll see the status as provisioning succeeded. In this demonstration, we learned that Applications and agents can be installed on the virtual machines in Azure through custom script extensions. These custom script extensions can be either picked up from the marketplace or you can write your own custom PowerShell script. Used by virtual machines and also cloud services on platform as a service. You can generally think of Azure storage in three categories. One is storage for virtual machines. This includes disks and files. Disks are persistent block storage for Azure Infrastructure as a Service virtual machines. Files are fully managed file shares in the cloud. Unstructured data. Now, this includes blobs and data lake stores. Blobs are highly scalable. They are REST-based cloud object store. Data Lake Store is Hadoop distributed file system, also called as an HDFS. Structured data. Structured data includes tables, Cosmos DB, and Azure SQL DB. Now, tables are nothing but just key value pairs. Cosmos DB is a globally distributed database service. Azure SQL is a fully managed database as a service built onto SQL. We will talk about these individual components one by one in the subsequent videos. Azure provides storage with the help of a service offering called as Azure Storage Accounts. Depending on your purpose and need, you would use blobs, files, tables, or queues. Let's talk about the use cases of each one of them one by one. Azure Blob Storage. Azure Blob Storage is Microsoft's object storage solution for the cloud.